Yes, it's MK the guy. For the mechanism of action, we say that the macrolides are protein synthesis inhibitors. And they are bacteriostatic. Remember, for the ribosome, we have the large subunit and the smaller subunit. The large subunit has the ribosomal RNA, which is the 23S ribosomal RNA. For the smaller subunit, has the 16S ribosomal RNA. This one also has the 5S ribosomal RNA. This is the 50S subunit. This is the 30S subunit. Now, for the macrolides, they bind at this position. They bind on the ribosomal RNA, which is the 23S, near the P site. We shall see clearly the P site and the S site in the video about the protein synthesis inhibitors. All those antibiotics which are protein synthesis inhibitors, we shall see them in one video. But it binds to the P site. This one will inhibit translocation. The growing polypeptide will not move from the S site to the P site. So this one will not occur. We shall not have the translocation from the S site to the P site. We shall have termination of the protein synthesis. The chain may be terminated prematurely. Binds at the 23S ribosomal RNA near the P site. We shall not have translocation from the S site to the P site. Hence, there is termination of the protein synthesis, and this can be terminated prematurely. Hence, these macrolides are bacteriostatic. When it comes to the cross resistance, the likes of clindamycin, chloramphenicol, and lincomycin, these ones, they also bind at the same vicinity, leading to the, if there is a resistance to the macrolides, we shall have also resistance to these drugs because they bind at the same vicinity. About the resistance, how does resistance come about? Can have R factor mediated, or the R factor enzymes methylation. Can have R factor enzymes methylation of the guanine. This guanine of the ribosomal RNA can be methylated by the R factor enzymes. This leads to the resistance. There is decreased affinity or the binding of these drugs to the ribosomal RNA. We can have mutation of adenine to guanine. At the binding region in the ribosomal RNA. This is also one of the mechanisms. We can have efflux by the efflux pumps. The drug is pumped out of the microorganism. Also, there is resistance due to decreased permeability. Especially this is for the gram negatives. There is decreased permeability. All these ones, the mechanisms to resistance to these macrolides. Let's talk about the erythromycin analogs. Yes, same the guy. About the erythromycin analogs, we are going to talk about these three drugs. One, the erythromycin. We talk about the erythromycin and erythromycin. Erythromycin was made by modifying the OH group. This OH is just a methoxy group now. This one is a methoxy group. The hydrogen was removed and substituted it with the methyl group at this position. This reduces the instability, or it increases the stability in acid. Also, the keto group, the one we have seen the mechanism, leads to the cramping. Now, this one, due to the presence of this methoxy group, there is acid stability, so it reduces the cramping. The GIT cramping reduces the GIT cramping. When it comes to azithromycin, at position 9 and 10, between these carbon 9 and 10, this is the carbon 9, and we have the carbon 10 here. This is 9, this is 10. They substituted an amino group here. So it will be like this. Here we have the methylamine. They substituted the methylamine at this position. And this O was removed. The oxygen atom at position 9 was also removed. This is position 9. Now this one will be the position 10. And this position 10 will be the position 11. This is its structure. Just substitute the methylamine at this position 9. Therefore, the removal of this oxygen atom, we shall not have the keto formation. So it also increases the stability in acid. Also reduces cramping. And also this drug, because of this substitution, it increases its half-life. So it can be given once daily. One tablet daily can be given because of the increased half-life. That's azithromycin. And so far, right now it's the first. If you think about using macrolides, it's the first drug. The first line macrolide. Right now. For erythromycin, this one, they added a keto group here. Instead of this sugar was removed and made this group a ketone. It is at that position. This is position 3. I think I should draw this one clearly. At position 3, it was made to be a ketone. At position 9, we still have a ketone. Then at position 6, to reduce or to inhibit the other mechanism, since we have the oxygen here, this group must be changed such that we don't have the cyclic keto formation. So this was made methoxy group such that we eliminate the other OH group, which is highly nucleophilic. Then at position 11, the OH group was removed, then amino group was substituted. Amino group was placed, then this oxygen at position 12, the OH group, they made this structure here. This is position 11, this is position 12. Then at this amine, we have this group. This is 1, 2, 3, 4. Then this is an imidaz here. This 1, 2, 3, 4, 5. You have imidazole ring. Then at position 4 of the imidaz, this is 1, 2, 3, 4. They added ring. This is 1, 2, 3, 4, 5, 6. This is imidaz. Shall have the bonds here, like this. And this one is a pyridine ring. This is imidaz. We see changes at carbon number 3, at carbon number 6, and also at carbon number 11 and 12. Erythromycin, it can be given for the macrolide resistant microbes. For those microbes which are resistant to other macrolides, this erythromycin can work. It's also orally active. It has a warning information that this drug can cause liver toxicity. Liver toxicity, and this is said that it is due to this pyridine ring. This pyridine ring can lead to the toxicity. This pyridine ring. We can talk about the drug interactions. About the drug interactions, these drugs, they are inhibitors of the CYP3A4. This is a microsomal enzyme responsible for metabolism of many drugs. For example, the anticoagulant like warfarin, antihistamine, theophylline, among others. So if it is inhibited, meaning that we can have increased toxicity of these drugs. For example, in warfarin, we may have more or higher bleeding. When we talk about that, this is the main drug interaction for the macrolides. When it comes to indications, these drugs are indicated for upper respiratory tract infections. This is because they have higher affinity in the upper respiratory tract, these drugs, and you can find the level of the drug higher in the upper respiratory tract than even in the blood. Also, for the lower respiratory tract infections, gastric ulcers, bacteria, endocarditis prophylaxis, gonorrhea. Those are some of the indications for these drugs. Then the ADRs, we talked about the cramping, the GIT cramping. In case of those drugs which have the OH group here and oxygen atom here, like erythromycin, you can have the cramping due to the internal cyclic ketone formation. There is toxicity, liver toxicity. For example, the erythromycin, you have seen it, cholestatic jaundice. Those are some of the ADRs for these drugs. Yes, it's MK the Guy. Thank you for watching from part 1 up to now. It's MK the Guy. Please follow, like, and comment.